In this tutorial, we're going to be focused on adding radicals. Now, one thing about adding radicals is you got to always make sure that the index, this little number that's above the radical, is the same. So I'm going to put here index must be the same. If there are different types of roots, or you have a different index, in other words, if this was a 3 and this one's a 4, then you cannot combine them, right? So just like we can only add like terms, consider that that index, if it changes in value, it's going to change its type of term, and the terms have to match in order to put them together. So just note that. That's very important in case you kind of get a trick question. And the roots must be the same. Now in this one, notice we do have an index of 4 on both of these radicals, which means they represent some value that's been multiplied together 4 times in order to get the radicand, the number that's inside of the radical. Because these both have the same, I'm going to go ahead and combine these. Now you might be looking at this first one, and I'll put this on here because it may look confusing because there's no number in front of it. But I'm telling you that I'm going to add it to this 8 fourth root of 10. Now notice, anytime we don't have a number, that means there's a 1 in front of it, right? Just like there's an invisible 1 in front of every variable, well, there's an invisible 1 in front of every one of these radicals if there's no number in front of it. So when we add this together, we have 1 radical of 10 plus 8 radical of 10. So I'm going to go ahead and put these together, and 1 plus 8 leaves me with 9, and it has that index of 4 with 10. And there you go. That's all we had to do on this first one. Very simple. Since we had like terms, we just combined the coefficient of each one. And when I say coefficient, it was just being multiplied to it. This 8 is just being multiplied to this radical. So technically, they're a coefficient. Now let's go ahead and take a look at example number 2. In example number 2, right, notice that we have 5 square root of x plus 3 square root of x. So we have these radicals that have an x in them, right? And since they don't have an index, neither one of them has an index, it's implied that that index is a 2. So these are both what we call square roots, or a root with an index of 2. So we're going to go ahead and add these two radicals together. Now our coefficients are 5 and 3. So those are really the numbers that we're putting together. So if we add these two together, the 3 and the 5, and they do have the same radical after them, it just becomes 8 square root of x. It's going to go to example 3. Now this one's going to be the most challenging. And what happens is, notice that we don't have the same radicand in each one of our radicals. For instance, the radicand is the number that's on the inside. And here we have the square root of 32. And here we have the square root of 72. Because these are not the same, we cannot simply just add them together. Because remember, I told you the index has to be the same. But also the radicand on the inside, they must be the same as well. Just like with fractions, you'd have a common denominator, you must have a common radical in order to add them. So what I'm going to do is I'm going to go ahead and we're going to simplify these so that we can go ahead and get the same root. So let's go ahead and start with the first one. I'm just going to put a number tree here, and what I like to do is I like to use my prime numbers to factorize them. So we're going to go ahead and simplify these radicals, in other words. So I'm going to put simplify radicals to see if you can add them. Radicand must be the same. And just a refresher from when we were actually doing some of these problems, if I were to draw you a radical and I were to put a number up here, let's put the number 3, and let's say we had a 27 in here. What I would like to note out is that this number 3 is called the index. This symbol right here is simply called a radical. And this value on the inside is called the radicand. And the answer to it, if we were to evaluate this, and let's put that in the calculator. If I were to take a cube root of 3, So I would hit math in my calculator and go down until I see the cube root symbol with a 3 in it, in case you want to try to evaluate some of these. And I were to hit enter, notice it gives me 3. And that 3 we would call the root. So let's go ahead, with that being said, let's break this down, and we're going to use our prime numbers. Now what I'm going to do is I'm going to write here prime numbers. And these are the numbers that I like to use to try to break it down. So I like to use 2, 3, 5, 7, 11, and 13. These will work for most of these radicals, just like you've seen in my other videos when we're trying to simplify them. And so I'm going to go over here and I'm going to see, can 32 be divided by 2? So I can go ahead and put in 32 divided by 2, and notice it gives me 16. So it can be. So here we have 2 and 16. Now I recognize that 16 is a perfect square, and technically I could stop there and go ahead and convert this. But let's say you didn't recognize that was a perfect square and you kept going. So we can continue, and I can say, well, 16 divided by 2 gives me 8. And then I could go ahead and do 8 divided by 2. That gives me 4. Now that's a perfect square. I could stop, but I'm just going to keep going. Let's say I just don't recognize it, and I'm going to stop. And we got 2 and 2. So notice these are all the factors. And so if I wanted to rewrite this, I could rewrite this as, and I'm going to go ahead and bring down the 4 first. I'm going to write it over here. So let me go over here to the left, and I'm going to put a 4 right there. Times, because this 4 is being multiplied to the square root of 32. The square root of 2. I'm going to write these in pink. Times another square root of 2. Times another square root of 2. And notice that I circle them as I'm doing this. And that way I don't accidentally forget to write 1. Now, remember that anytime we have 2 radicals multiplied to itself, it just becomes the radicand, the number that's on the inside. So for instance, these 2 just become a 2. So I'm going to bring down my 4, so it's 4 times 2 times, these 2 become another 2. And this one right here, notice there's not another square root of 2 to multiply it to. So I'm just going to simply write a radical of 2. Now I can multiply this out. So I can do 4 times 2 times 2. Now if you're not good at multiplication, right, you could just throw it in the calculator. 4 times 2 times 2. And it gives me 16. So all this multiplied together gives me 16. And then I'm going to bring down my square root of 2. Now we are not done. This is just me simplifying this, because my goal is to simplify the radical in hopes that when I simplify the radical on this second term over here, the 2 square root of 72, it also has a third of 2, or basically a square root of 2 left over. That can't be further simplified. And that way they'll have the same radical, and I can combine those 2 coefficients. So let me show you what I mean. I'm going to go ahead and I'm going to use my favorite number again, 72 divided by 2, and it worked, 36. So 2 and 36. Now this time I'm not going to go through all the trouble of breaking it down over and over again, because I do recognize that 36 is a perfect square, and anytime you get a perfect square, you can actually stop at that point. So I'm going to go ahead and write this as 2 times this first one, square root of 2, times the second one, square root of 36. And the only reason I can stop here is because this is a perfect square. So you can always stop when you hit a perfect square, or if you hit one of these prime numbers. That's how you know that you've factored it out enough. Now this square root of 36, if I were to put that in my calculator, for those who were not familiar, who didn't recognize that's a perfect square, if I were to go ahead and take the square root of 36, notice it gives me 6. So this actually turns into a 6. And then I'm just going to bring my 2 down. So I have 2 times this 6, so we got rid of that. And then the square root of 2 is left over. Now if I go ahead and multiply this out, 2 times 6 is going to give me 12. And then I'll bring down my square root of 2. So now what I really have, if I rewrite this nice and clean, we really have 16 square root of 2 plus this one, which is 12 square root of 2. So by simplifying the radicals, we now have like terms, right? Because they both have a radical that's a square root of 2. And we can go ahead and combine these now. So now I can do 16 plus 12. So 16 plus 12. And that's going to give me 28. And then the square root of 2, I just write it after it one time, because it's just being added. And that's my final answer. So notice right there was some work that we had to do in simplifying the radicals, and you will run into this sometimes when combining radicals that have a different value as the radicand. Now, one last thing that I want to tell you, for those of you who are looking at this going, well, Mr. H, what if I made a mistake? Is there any way I can tell if this is the correct answer, given that these two are being added together and they weren't alike, so I couldn't just combine them? And the answer is yes. We can always use our calculator to check to see if it's right, because the calculator, what we can do is we can add these two in there, it'll convert them to a decimal, and then we can compare that answer to this final answer we had that'll also be converted to a decimal. And if they both have the same answer, then we know that we did it correctly. So I'm just going to give you an example. I'm going to go ahead and put these in. 4 square root of 32. And then I'm going to put plus 2 square root of 72. And I'm going to hit enter. And notice it gives me 39.59 and some random numbers here, right? So now I'm going to take my final answer, and if I did this right, it should also give me this same answer with the same decimal strand. So I'll do it 28 square root of 2. So 28 square root of 2. Right? That was my final answer after simplified. Now we call this an exact answer, and anytime we have a decimal, it's an approximated answer. And most of the times, if they're having you add these, your teachers are going to be asking for an exact answer. So you do need to know how to do it by hand. However, when you get done, you could check it with a calculator just like this. And notice I have the exact same answer. So even this is the expression we were given where they were being added, and this down here is the final answer. When I put it into the calculator to evaluate it, it gives me the exact same values. So I know that I did it right.